Hello, everyone. I'm Raymond Wolfgang. I work for U.S. National Lab and also very involved in INCOSI, the International Council on Systems Engineering. And what you're going to hear today is a walkthrough. You're going to hear and see a walkthrough of a very helpful SAE spec. It's the airspace standard AS5669. And that is the JAUS SDP Transport Specification. I'm going to go over what that is. Matter of fact, how this is going to work is we're going to start with the spec itself. It's a PDF diagram, but the real gem is we're going to jump over to CATIA systems modeler, and we're going to see how there is a model that goes with the spec. So if you're looking for requirements for this, and the SDP is a software-defined protocol. So this is a communications protocol designed for low bandwidth autonomous vehicles. They use UDP, and basically it gives headers and just all sorts of requirements if you want to implement this spec in your application. Okay, which is great. So you don't have to reinvent the wheel. Okay, so this is a big deal. And if you have a systems model in Magic Draw or Cameo, you'll be able to import this AS model in there and then tie into their requirements, which are already written. It's already vetted. It's going to save you all sorts of time, and it's going to prevent you from reinventing the wheel. Okay, so we're going to lay a little bit of context so the actual diagrams make place. So I'm going to share the screen. There we go. So here's the airspace standard, and the model's in the background, as you see. Now, this is, it could be in conjunction with some things, but basically, it's the JAUS SDP Transport Spec. So this is a application layer, and even goes down to, I believe, the link layer as far as what it covers. So let's get in here. So you got the scope. It's the joint architecture for unmanned systems or other software-defined protocols. And this just defines formats at the low level. And yeah, you'll see things at the application layer, but it also goes to link layer details. So you can give this right to your programmers and they can be off and running. So we'll see this both in the model, and if you want formats, it's also all in this PDF document. So this is the spec. The model is a very helpful add-on. And if you want more information on JAUS, there's a report there. But basically, we're going to jump to page 9. And here's the context of it all. So you've got two applications have to talk to each other. Well, they have to go through a transport layer and then down to the actual communications medium, the link layer. If you're familiar with the OSI model, the 7 layers in the IT field, this is a similar idea. So applications need to talk to each other. Maybe you have a drone, okay, and you have a telemetry link, telemetrized communication there. You're taking data back and forth there. Maybe between 2 drones that have to talk to each other, or between a drone and a ground station of some sort. So this is the context. And the document itself goes through different capabilities where we're transmitting packets. There are requirements on corruption checks on the packet data. And this is going to be important when we look at the requirements over the model. Now, you also have different semantics that you have to conform to. And this can be adapted to other software-defined protocols too. It doesn't have to specifically be for an unmanned vehicle application. However, there are requirements, as you see, for data reduction and data compression, again, for low bandwidth environments. And to boot, it throws in, there's a requirement for a process to discover the addresses of the other AS5669 compliant entities that are in the space and then visible. Okay, now we'll introduce this real quick, then we'll jump to the model. It goes into, here's 32 bits. Here's your payload. It's those familiar with the TCP/IP protocol. You'll see a lot of similarities here. Then you go into message types. It defines the header and goes from there. So, and then I'm just going to quickly page through it. After the definitions, you have definitions of flags. So it's all in here. And then you can get different groupings as well. But here's the thing: you can give this to one of your, you can give this to your programmers. So you can give them the PDF document that says, hey, look, this is the protocol we want to get. Why don't you draft this up into a model, maybe write some requirements around it, and maybe we'll get a test bed going. So-and-so maybe had done software before, or software protocols before, and you can get started. Or you can actually go to the Cameo. So what we did here is we've got, I'm going to show the model here. We can jump over to a magic draw model of basically of this whole entity. So now we will, if you start here, you know what, that is not a great place to start. So the first, when you go to this model, it gets loaded in. So you do file, and you could do import from. So you want to do import from another project, and then it'll let you browse around, and then you can do the right. I think I put it under downloads here. So you would download the. Let's go. Okay, so you would find the right file, uploaded here. And then what that looks like, if you look at the far left, we've already loaded the AS5669A spec. You can see it there. There's the model. So we've imported that. Then as you look on the left here, this model goes through the document, but not only goes through it, it'll have text items here. So this just shows you what the purpose was, which we just saw. We'll zoom that up a little bit. Okay, and then you have the next one. However, here, this is a bit more interesting here. Here's the system. Wolfgang UAV 2. I figured it's why have the show the first one. So, but what this does is this allows you to tie to your model different requirements that come up. These are the compliance requirements. And then if you look at the left here, you've got the support compliance assessment. There's a requirement, and then here's the diagram. Okay, here's the text, the properties, and you can see more properties there. You can expand it as you see fit. But here they are. This requirement has, two sub requirements. Over here. Sorry, the summary of result transport rules. Your diagrams are here, and then you see it over in the containment tree over here, and you see these are requirement blocks. I'm sorry, requirement types. Now, that's point 2. Let's go back to the PDF. We'll look at section 1.2, and we're going to see. Pardon the jumping around here. See, here's 1.2 compliance, and you've got some requirements here. All transport packets shall state the version. Transport shall not modify the content of any transport payload. Okay, let's go to here. There's modification of content or format. Transport shall not modify the content or format of any transported payload. So there we go. It's right there. Now, if you keep going, okay, so it's broken. The model's broken up by the section header, and we won't go through every section, but we're going to deep dive on a few of them here. The nice thing here is that you've can have tables here. So here's the tables of references, applicable documents, And that's in and amongst the different text snippets. You know, if you don't want to, if you want the text right here, that's helpful. We're going to close some of that. That is, as we go down to the 3, the context. Okay, remember section 3 here. Context. Okay, now we're starting to get into some diagrams and talk about the layers. So the good thing is we can have, so we have relations here, like a typical Cameo. We have relations, we have the required capabilities, and you could bring these up. So here are your required capabilities. I'm going to zoom in a little bit. Message priority, and then here we have the requirements. As the go into detail there, we bring that up. So the other required properties. Now we want to go into structures here. So let's get a diagram. So that's that. Oh, by the way, for the compliance for that earlier section, here are the requirements in a nice spreadsheet. A lot of times, my current employer, our customer wants things in spreadsheets. You know, it's because that's what they're used to. So the Cameo does let you have a requirements table here. That's I haven't exported this particular one, but this does. It allows to present to the customer either in the tool or possibly via an export. I'm not an expert in that, but give you something the customer wants, because at some point, you know, if they're paying us, they want it in a certain format. You know, we try and lead them to water for the MBSE work, but you know, again, the customer is not always right, but they are always the customer. Was what one of our VPs always said. So, you know, and he had a good point. Now, if we want to, we have the blocks over here. Okay, you can see the under structures. We've got the application, communications medium, and transport. So let's look at the diagram for that. Okay, so here is a interface block diagram. It's that. Okay, so here's the context. Okay, this is the same thing as what we saw here. Okay. We've got again, so applications. So app 1 and app 2 are instantiations of an application. We've got the transport, and then we can show this in the containment tree. That's down here as a part property. Yeah, so we got that. Okay. I'm sorry, it's an internal block diagram. I was thinking interfaces here. So, but anyhow, it's all here. So we've got the pieces. Okay, here's the transportation context, and it's all right here in the model. So it saves us from having to import it. Now, if you go to a different, here's a block diagram of the context. That is the one that's this one here. In fact, we're gonna verify that. Yep, we're good. Now we've got the overall context, and then we have the application, we have the communications medium, and then the transport. Okay, you get very high level, but these blocks are already there. And then, you know, it's semi-populated here. Then you can always go in, and if you want to see other things, there might be some operations. This one's okay, so we can blow this up if you want to see more things here, but we don't necessarily need to do that. Nope. But you know what? We're just going to. Okay. All right. Point is, you have the blocks there. You can expand them as you see fit. All right. We're not going to shoot too much of that. You know what? We're going to get rid of it. You can always bring it back. Okay. So that's section 3, lays the top level. Now we go to section 4, and you've got other things as well. Okay, we're going to look at the section 4 requirements. We have a different set here, and now there are a whole bunch of more requirements as far as what goes on. You have transmission ones, some transport requirements. So these are all in 4, and if you expand some of the things over on the left here, then you're going to see, some of these other requirement sections as well. So they've got quite a bit here. You can page through these. But what let's see, and then you have the relations here as well. So in fact, I think you could do, yeah, here we go. So these requirements are way down in the message definitions. Now you've got some of these requirements in there. So notice how you can just right click here and say select in containment tree. And then that's where you find it. Now that's a tool thing. It's not a SysML thing, but I use that all the time. So now that again, the benefit here though is you don't have to pay your engineers to look through the spec, this PDF document, and just come up with what the requirements are. SAE has produced a model that'll just get you a head start. Now you still need to do simulations, you still need to test, and we still need to design our system. But again, we're about not reinventing the wheel. Now the other things that they have is they've got the signals. So if you look at the different signals here, you've got the properties, because there's a lot of things going back and forth. You've noticed on the side here, here's some more signals. You've got this one, it's a bit sequence. It contains a Boolean. It's more bit sequences here. Yeah, here you go, 16-bit. These are different types of signals. So even those are defined. Okay, well, we'll keep going here. The transport standards, they're here as well. Again, you've got requirements section, and then you've got the header compression. You have a satisfy matrix here. Okay, so now we're talking about requirements traceability, classic systems engineering. And you see what's basically that's the crosswalk satisfy matrix. It goes by different names. So Doors will also produce this. I think it's a little harder to do in Doors, or at least Doors Classic. So here, yeah, you have this satisfies any of the requirements up top. Then you have different signals on the left. So again, one more thing your engineers don't need to do, and then you can see other requirements. So okay, so it goes again for section 6. You've got this for section 7. If you want to do this over serial, is section 7 over IP. Again, you've got requirements, different things here. Structure, we'll just take a look at another diagram here. Here's just a block diagram with doing JAUS over UDP. Okay, you have the block and then you have the message and different things here. So 7 does over serial, and we can look at the serial definition. Okay, again, you've got your containment arrow and different blocks. Now there's an appendix here. There are two things here. There's the appendix, and again, all this. If we go to the table of contents, let's see. We won't get bogged down there. But basically, you have the different things here that's defined in the model. So a lot of this, here's section 5. A lot of this document is describing syntax, basically, of this transport layer. But here's number 6. Here we'll do just look at one more thing here. Here's a transport format, and this is section 6. So you're doing doing it over, let's see, I think it was UDP. Yeah, doing JAUS over UDP, so it tracks along. In fact, here it is, the transport structure. Okay, so we're wrapping it up here. You got the appendix. That also have requirements. There's section 7, pardon the real scroll here. Here's other things in the appendix, and then that, you have parameters here. Go back there. You've got that in the appendix also for some requirements. You can bring up a dedicated requirement trees. Looks like it's displaying 19 out of 24 total rows. The requirements there, and then you go into your structures. Now you've got blocks here. And then some value properties specific to the library. Here's value property of size in terms of byte. And then for, we'll just take a look at some of this. If you need to bring in, an Ethernet header, your IP header, you've got the structure right here defined in your common library. So those go back up. And then if you're doing a massive review, you want to do a line by line thing, you can even show the long list of requirements. So you got 339 total rows. Some of them are hidden. So here's the thing though, you've got, your requirements defined, you have signals defined, you've got structures, you got, logical architecture here. You've even top level diagrams. So a lot of it it's going to save you time. It tracks the actual spec. So it tracks the PDF. So PDF is the master and this drives from it. But especially if you have some people on your team very savvy with the tool, you can have them really look at this, bring it in. And then when you go back to, your top level design here, you've got, you do your structure, then you can start adding these things in at where appropriate, and then start doing spend your design effort doing the others. Designing your custom system, not just the protocol, which has already been established. Okay, one final thing. It also has it describes a signal, which is the general transportation header. I'm going to find this in the containment tree. Okay, so it's down here. It's section 4, general transport header. You can see different messages. But this, gives you basically these signal architecture of this header. You can see the ACNAC is here, you got the flags, you got the payload, and then this is an added image from the document to help along. But this again, this is signal heavy. Here it is. If you need to refer to some of this, you can pull this, and then it's available when you do let's see, when you're developing your model. Okay, and let me get the okay, there was one model. I got a lot over here. Yeah, here we go. So here's other things. This is at the top of the containment tree. If you set it up right, this is going to have visibility into all these other lower level requirements and signals and part properties and block properties and so on. So in conclusion, this was all just done by importing the AS5669A model, which they had a MD-zip file, SAE, put it in there. And now I've one less thing to worry about because I have all the protocol diagrams that I'm going to need. That I'll need to tailor and customize perhaps, but now I can focus on filling in the rest of Wolfgang UAV2 versus just spend what could be months just recreating that spec. Now The end result, of course, is to build a product, and if we could save 4, 6, 8, gosh, even 12 weeks of development time, it's worth it. Now, if you have any questions, reach out. But the purpose of this, what I hope is the main takeaway, is that if you're looking at really creating a Cameo model, it doesn't have to be Cameo, but other things, you know, if you need to be compliant with the standard, okay, you want to do that. Either your customer dictates it, or that's just something you want to do. See if there is a model file for this standard that can help you get started. Also, it doesn't just go for standards. You know, you could save a lot of time if you could find some libraries, model libraries, either within your company or within your professional society. Sometimes they'll have the basic parts that you need to do your application. So, okay, that's the walkthrough of the AS5669A. I'm Raymond Wolfgang, and I'm available on LinkedIn. Reach out for any questions, but please, the time you save will be your own. And if the model's already built, it can help you along, why not use it? Have a good day.